Team number 9, Angela Grozos,
Thomas Gabriesus.
Mariah Harris.
Our heat exchanger utilizes concentric tubing in a helical shape and operates under counterflow conditions, with the hot water going through the copper tube in the opposite direction of the cold water in the PVC tubing. There is convection at both the inside and outside surfaces of the copper tube into the cold water within the PVC, and conduction through the walls of the copper tubing. To create our heat exchanger, we placed the copper tube within a PVC plastic tube, as well as 2 PVC T-fittings. Copper was also used for the male ends of the push-to-connect fittings. The thin copper tubing had an outer diameter of 1/2 inch, while the PVC plastic tubing had an inner diameter of 1 inch and an outer diameter of 1.25 inches. We first brazed the copper wire at various locations along the copper tubing, and later inserted the copper tube into the PVC plastic tubing. We then bent both tubes around a cylindrical surface and placed the T-fittings on the inside of the PVC tube, but outside the copper tube. To secure the fittings, we wrapped several layers of waterproof tape around the copper tubing, as well as epoxy to ensure no leakage.
During our first evaluation, the heater was not operating properly and would not heat the water above 40 degrees Celsius. In this trial, the hot water inlet temperature was 39.5 degrees Celsius and the outlet temperature was 30.3 degrees Celsius. The cold inlet temperature was 22.2 degrees Celsius and the outlet temperature was 27.5 degrees Celsius. The hot water flow rate was 3.4 liters per minute and the cold water flow rate was 5.09 liters per minute. Under these conditions, our system experienced one small leak at a point along the T-fitting.
From our first evaluation, we learned that we need to extend the epoxy material further onto the T-connector to prevent further leakage. For the next iteration of our design, we will use a PVC tubing with an inner diameter of 3/4 of an inch to induce more turbulence between the PVC and copper tubing. To reduce the deformation of the copper tubing, we will be using a different manufacturing technique to coil the 2 tubes. We think that the deformation was caused by the flexible PVC collapsing on the copper tube and flattening it. We will prevent this unwanted deformation by filling the PVC with hot sand, making the PVC more malleable and preventing it from collapsing onto the copper tube.